So here we're gonna go through some 9 built-in functions or modules, whatever you call them. They are critical to know to every developer who's using Python on his daily basis or for a job. So basically we're gonna go through them one by one. Most of these examples are taken from the book Fluent Python. I'm gonna leave a link to that book in the description. You should really buy it, there's lots of useful information there. So, without further ado, I'm just gonna do some small changes, like copy this and comment it out here. So, first is the counter module from collections. Basically this one is good for counting elements inside of our iterable. What it does, if you look at the source code, basically what it does, it finds the duplicate elements, returns them, or sorts them out how you wish. Personally, I've been using it if I would have needed to find a duplicate inside of a list or whatever, and I'm pretty sure that you're gonna come across it, so let's look into it. It's very basic. You create a counter, just give it an iterable, and here we're looping through all the items. It returns a dictionary, and we see if the value is higher than 9, then we found our duplicate. So let me just make this bigger. So we have 2 duplicates, which is A and E, and here they are. So we can also sort them out, and we can print 2 the most common used ones. So sorted basically returns us a list without any duplicates. It's basically the same as a set. And here we have most common 2 returns A and E elements. If we put 1 in it, you just get the first element. 1 element, I mean. And here we have 3 elements. So, that out of the way. Next is the item getter. Very useful if you're working with a dictionary. So here we define a list of dictionaries. Basically has a key of first name, last name, and an address. Here in the explanation, in this example, we insert a row into sorted function, which has named key parameter. Key argument has to be callable, which accepts 1 element of rows and returns found key from row, which will be used in the sort. The function operator item getter takes in indexes as arguments, which are used for extracting the correct element from the row. It can be dictionary key, number of elements in the list, or any other provided value that can be fed to the method get item. So basically it accepts anything that get item uses. And if we take a look, item getter, this attribute getter, and so anyway, it's built in somewhere. But what we're gonna do is we're just gonna look at all the rows that are sorted by the first name and by the last name. So actually let's just do the first name. So the first name is Jane. If we go here, then our first dictionary is actually John. Here it gives us the Jane. John is second, Robert is third, Ron is fourth. So yeah, let's take a look by last name. Now John is first, Jane is second, basically Bob, Janet, and so on. What good it is about item getter, you can actually specify 2 or more key values that you want to look up. So in this example, we're looking it up by the first name and by the last name. So if I print Jane and Janet, well, this doesn't make actually much sense, but it does what it does. So if you're working with dictionaries, this is very critical to know. You can of course use lambda expressions, but item getters are faster in most use cases and it supports more than one key lookup. So I'm gonna actually delete these. And next is attribute getter. I'll read the explanation. So it's good to sort out objects of a class if it doesn't support comparison. You can also use lambda functions instead of getters. It's a matter of taste. In most cases, attribute getter is faster than lambda and it supports extraction of multiple fields. So what I've done here is I created a user class. It simply has user ID, username, and a representation of that class. Here I make a loop in range of 10 and just create new users. Here I sort them out by username. Here I sort them out by ID using attribute getter. Here I'm using reverse true because otherwise we're gonna just see one and the same result, even if it prints out different items. So here it prints the 0th user, first, second, and here it simply prints it all in reverse case. There aren't actually enough data variables to work around it, but just to get the basic idea. Next is group by. So a use case for it: you have a list of dictionaries or other key value pair elements and you want to iterate through a specific keyword, for example a date. So list of dictionaries, each has 2 key value pairs, a date and an address. So here we printed out the default rows before editing them. Next we sort them by the date and we print them out again. So I'm just gonna uncomment this for now and group items. So before our first add, this is the raw format. First address was 5412 and here is 5645. So that works. Next let's actually iterate through it. So here for date and the items in group by, we give it a iterable and the key is date. Basically it returns the date, and items, it's an iterable. Here we print out the date and then we iterate through each element in the item and print it out. So like this, it has a date and each element that has the same date is addressed in the same row, which is nice. If you're working with some timestamp like items, this is very good to use and very handy. So the second example, we have an input, a list of dictionaries. It has a dep, a SQI key, a transition ID and a quantity. Some of them are identical. Here for example we have two foo's within the same dep. Here we have two bars and these are unique. So first we're gonna get the output based on aggregation. We define the fields that we need to a grouped variable. So, and what we're doing here, we're giving it a key. So for the key and the group in group by, we sort it out inside of this group by callable. We give it an input, which is our list. We give it the key, and this was the key for the group by. Next, to create a temporary dictionary, we create a dictionary and we zip in these keys and giving them these values. Next, we're creating the same temporary dictionary. We're giving it a quantity key and we're just summing up all the items in the quantity which are inside of this iterable, and we're just appending this temporary dict to the aggregate result. So first I'm gonna print out the result. Getting a generator. Aggregation results. That's weird. Will this behave the same way? Yep. Which it shouldn't. Okay. No, that didn't help. Anyway. No, this is too ugly. key plus okay, let's go what we have. Yeah, it's too early. Key plus value. Yep. Finally, so based on aggregation, we have 5 elements. Basically what it does, so for the first element, we have a bar, which is 200, it's here. Then we have a foo as a value, which is this one and this one. Basically put them together and returned their total quantity. The same for every other one. So let's actually look what's going on here. So I'm gonna uncomment this out. We're just gonna print the key, and we're gonna print out the temporary dictionary, and we're gonna print out the temporary dictionary again. So what's going on? This is the key that we're getting, which is the depth and the SQU. Next, we're creating a dictionary out of the keys that were provided, which is depth is 001 and SQ as bar. Next, we give it a quantity, key, and assign the value to it for each value that is inside of the same depth and SQ key, which is 200, and the same for every other element. So next, we're sorting it out by average. Basically it's the same functionality that here, except here we're creating a temporary list. So inside of the list we are sticking in the quantity of each item that has the same depth and SQ value, and instead of a quantity value we give it an average, where we sum together the value of the temporary list and divide it by how many elements are there. And next we simply append it to a list. So I'm gonna just print it out. Yeah. This went. This isn't the result that I was actually. That's why. So let's take a look. Here, the first step, that key SQA bar, which is this one, doesn't have anything else. As for the few, the value is 200, since it's appending this element and this element. In total, that's 400 divided by 200, and you have your average value. Next, the chain dict. Basically, if you have used the chain, the same principle. If you need a specific key or a value, you create a chain. It accepts n amount of iterables, which in this case are 2 dictionaries, and just loops through every one of them until it finds the desired value. So here we're searching for the third key. Found the third and prints the third. There's nothing special with this built in. So next, text search. This contains simply what string ends with and starts with. Basically, we create a file name, spam the text, and here it returns either true or false. The first one if the file name ends with the text, and the second one if it starts with the file. And here we create a URL, and we simply check if it starts with HTTPS, so it should return true. And here's one more example. We're creating file names from the current list directory. We print them out, and here we print out each file which name ends with pi. So let's look it up. So does the file name end with text? True. Does it start with file? Typo, which is false. Does the URL start with HTTPS? It's true. And here it simply prints out all the directories and files that are in my current path, finds the one that ends with pi and returns it. So, text search out of the way. Next is round values, pretty straightforward. It takes a value and rounds it up. And if you see here, takes this value, rounds it up to 1, takes this value, rounds it up to 2. Very handy. And our last one is partial. So, a use case for partial. Let's say you have a callable that you want to use, but it accepts too many arguments and throws an exception. If you need to limit the amount of arguments of your callable, use functools partial. Partial will allow you to declare a fixed amount of arguments that a callable can receive. It's a nice thing actually. You can of course use the abstract base class Python provides, but in some cases this is more effective depending on your use case, of course. So here we define a function inside of a function. It simply returns its arguments. Here we define partial, we give it this function and we assign 1 to it, which means it's the default value for the A is 1. Same here. We defined another partial variable, but D has 42 of default value. And for this tree, basically the same thing. And here we just give some more default values. If I'll just print this out, so where does it start? It starts from here. So 1, 2, 3, 4. We gave one a base value we gave a base value of 1. So in this one we gave D a base value of 42, and here we defined 4, 5, 5, which are the first 3 elements. Then in the third one, the A is 1, B is 2, D is 42. And here we simply put 5. So it actually found the element that wasn't defined by default and assigned it to it. Here I'm just putting out something that's unnecessary, but that was basically everything I wanted to tell you. So these built-ins are very useful. You will need them in your daily basis if you're working as a software engineer. I hope you like it. I'll leave a link to my GitHub in the description. Smash like, subscribe, and see you next time.